Welcome back to section 5.3. We're going to be continue on with solving. Make sure you have your values for when you have pi over 6, pi over 4, pi over 3, etc. So we're going to still isolate. So we're going to get tangent squared by itself by adding 1 to both sides. So 3 tangent squared x equals 1. Divide both sides by 3. Tangent squared x equals 1/3. Now we're taking the square root of both sides to get tangent by itself. So the tangent of x equals, don't forget, two solutions, plus or minus. Now the square root of 1/3, the square root of 1 over the square root of 3. So that's 1 over root 3. So when you rationalize, multiply by root 3 over 3, you get root 3 over 3. So tangent of x equals plus or minus root 3 over 3. Now tangent, when it's positive, we're in quadrant 1 and quadrant 3. When it's negative, we're in quadrant 2 and quadrant 4. Now when tangent is going to be a root 3 over 3, that's going to be at a pi over 6. So we're going to have a pi over 6 in quadrant 1. And to be in quadrant 3, it's going to be a 7 pi over 6. That's for our positives. For our negatives, we're going to be at quadrant 2, which is a 5 pi over 6, and quadrant 4, an 11 pi over 6. So now, x equals, if we're looking at from 0 to 2 pi, pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. So just put them in order. That's our solutions from 0 to 2 pi. We're in every quadrant. Now, if we want to think about the general form, all of the solutions, if we want to think about all of the solutions, think about where we're at. For our positive, we're in quadrant 1. Here's our pi over 6. And in quadrant 3, 7 pi over 6. Those are all n pi apart. For our positive solutions, x equals pi over 6 plus n pi. That's going to get us those positive solutions. For the negative ones, x equals 5 pi over 6 plus n pi. And there is our solutions in the general form. Problem number 10. We're going to isolate that sine squared. So we're going to add 3 to both sides. So we get 4 sine squared x equals 3. Divide both sides by 4. Sine squared x equals 3/4. And take the square root of both sides. So sine of x equals, don't forget, two solutions, plus or minus. And the square root of 3/4 is the square root of 3 over the square root of 4, which is the square root of 3 over 2. So you get plus or minus root 3 over 2. Now, sine is positive in quadrant 1 and quadrant 2. Sine is negative in quadrant 3 and quadrant 4. So we have to take into account the positive solutions and the negative solutions. So when sine is root 3 over 2, that's going to be our pi over 3s. So for quadrant 1, pi over 3. And for quadrant 2, 2 pi over 3. In quadrant 3, that's going to be 4 pi over 3. And also for quadrant 4, 5 pi over 3. So our solutions, if we're looking at from 0 to 2 pi, pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. That's our solutions from 0 to 2 pi. Now, if we think about those graphically, pi over 3 is right here. Now, 2 pi over 3 is here. 4 pi over 3 is down here. And then we're at 5 pi over 3. Now, these, pi over 3 and 4 pi over 3, they're pi apart. And so are the 2 pi over 3 and the 5 pi over 3. So what we can do, those are pi apart. And these two are pi apart. So if we write the general form of our solution, so all of those solutions, it's going to be x equals pi over 3 plus n pi, 2 pi over 3 plus n pi. There's all of our solutions in that general form. Problem number 11. Here's another type where we have to factor. So looking at this, we're going to get it equal to 0. So what we're going to do is we're going to subtract 2 cotangent of x from both sides. So we get cotangent of x, cosine squared of x, minus 2 cotangent of x equals 0. We can factor out a cotangent, so we get cotangent of x, and that would give us cosine squared x minus 2. Okay, so now it's factored. Set each factor equal to 0. Cotangent of x equals 0. Cosine squared x minus 2 equals 0. So cotangent of x equals 0. You can do this a couple different ways. At pi over 2 and 3 pi over 2, that's when our cotangent is 0. So we would have pi over 2 and 3 pi over 2. If you forgot that, you can also write it like this. Cotangent is cosine of x over the sine of x. Now that equals 0, which is the same as 0 over 1. And if we cross multiply, 1 times cosine of x is cosine of x. Sine of x times 0 is 0. So if you remember, when cosine is 0, once again, that's at our pi over 2 and our 3 pi over 2. So x equals pi over 2, 3 pi over 2. So a couple different ways to think about it. If you remember the cotangent values, or write it as cosine over sine and work it that way. For the second part, add 2 to both sides. So you get cosine squared x equals root 2. 2. Take the square to both sides. Cosine of x equals plus or minus 2 solutions, the square root of 2. Now, the square root of 2 is about 1.41. But for cosine, we can only take the sine and cosine of a number between -1 and +1. This is too big. This does not exist. We usually write DNE for short. So our only solutions are are pi over 2 and 3 pi over 2. Those are our two solutions from 0 to 2 pi. Now, our general form for that, would be x equals pi over 2. Those are both pi apart, so plus n pi. That would give us every single solution. Let's try one like number 12. Once again, get it equal to 0. Subtract 2 sine of x from both sides. Sine squared x minus 2 sine of x equals 0. So what we can do is we can factor out a sine of x. That would give us sine of x minus 2 equals 0. Now that it's factored, set each factor equal to 0. Sine of x equals 0. Sine of x minus 2 equals 0. Now remember your quadrant angles. When sine is 0, that's going to be when x is 0 and when x is pi. Now, when sine of x equals, or sine of x minus 2 equals 0, add 2 to both sides. So sine of x equals 2. We can only take the inverse between -1 and +1. This does not exist. It's outside of that range. We can't take the inverse of a number that's not between -1 and 1. So our solutions from 0 to 2 pi would be 0 and pi. Our general form. They're both pi apart, so x equals, and what we can do, it's just n pi. If n is 0, it's 0. If n is 1, we're at pi, n is 2, we're at 2 pi, 3 pi, 4 pi, and so forth. That gives us all of our solutions in the general form. Next page. We're going to find all of the solutions. Now, this is a quadratic type. So what we can do, 2 sine squared x minus the sine of x minus 1. Now, let's make the sine of x equal to y. So what we have here is 2y squared minus y minus 1. We can factor that. That would give us 2y plus 1, y minus 1. So now, putting back that sine of x, it's 2 sine of x plus 1 times the sine of x minus 1 equals 0. It's factored. Now, just like we've been doing, set each factor equal to 0. 2 sine of x plus 1 equals 0. Sine of x minus 1 equals 0. Subtract 1. 2 sine of x equals -1. Divide both sides by 2. Sine of x equals -1/2. Add 1 here. The sine of x equals 1. Make sure you have your unit circles out. Now, when x is a -1/2, when the sine is a -1/2, negative, that means we're going to be in quadrant 3 and quadrant 4. Now, when sine is 1/2, that's going to be at our pi over 6. So x equals something pi over 6. To be in quadrant 3, it's going to be 7 pi over 6. And to be in quadrant 4, that's 11 pi over 6. Now, when sine is 1, don't forget about those quadrant angles. That's when x is a pi over 2. So now, x equals 7 pi over 6, 11 pi over 6, and pi over 2. Those are all of our solutions from 0 to 2 pi. The general form. if we think about it graphically. Now, there's 7 pi over 6 and 11 pi over 6. They're not nicely spaced. And here's the 1/2 up, or pi over 2 up here. Nothing is equally spaced, so to go all the way back around the circle, we just have to add our 2 pi. So it would be x equals 7 pi over 6 plus 2n pi. X equals 11 pi over 6 plus 2n pi. And x equals pi over 2 plus 2n pi. That's all of our solutions. No nicer way to write that one. Let's go to problem number 14 now. Once again, actually, I'm going to save this for another video. All right, thank you, and I will see you in the next one.